Okay, so this is part two of chapter 12, perfect competition. In part one, we defined what are the characteristics that help us determine which type of competition, perfect competition being the first type that we're going over, that an industry meets. In this chapter, we're assuming we're going to be looking at companies that are best categorized as being in perfectly competitive markets and creating the decision rule to determine what quantity of output they're going to produce to maximize profit and how you would then calculate the level of profit they're achieving at that profit maximizing quantity. And spoiler alert, it's really not different than we talked about in chapter 11, nor will it ever be. The choice being produce the quantity where marginal revenue, the last time marginal revenue is greater than or equal to marginal cost. So let's do it step by step. Okay. So first step, again, reminding us or being clear what we mean by marginal revenue. Marginal is always how much something changes. Marginal revenue, how much revenue changes when we produce and sell one more unit of output. And what we're going to be looking at is tons of wheat. 1 ton of wheat being our unit of production for our farmer. So the formula, right? Marginal revenue, the change, delta for change, triangle, change in total revenue divided by change in quantity. And in the table of numbers we're going to be looking at, the change in quantity is always 1 as we go down the table. So marginal revenue will literally be how much revenue changes when we produce one more. Now, this concept of marginal revenue is relatively straightforward to what it is for a company in perfect competition. Marginal revenue is simply the price that they're selling the product for. Okay? Because every time they can sell as much as they want at the market price, whatever that is. So that means, unlike a company facing a downward sloping demand curve, they don't have to lower the price to sell a higher quantity. They just produce a higher quantity and they can sell that, right? From part one, they can produce as much as they want at the market price is the assumption in perfect competition. So marginal revenue and price are one and the same. That will no longer be true for the other types of competition, and we'll discuss why when we talk about monopoly in the next chapter. Okay. So from here, I'm going to jump over to an example that we're going to use in Excel to evaluate this. Right? So here we have tons of wheat. Right? So anywhere from 0 to 7 tons of wheat. Market price, same as it was in part one. We're going to assume the market price of per ton of wheat is $200. And then we're going to just in this table fill it in, calculating total revenue at each quantity and marginal revenue, how much the revenue goes up each time we produce one more. So what does it mean? They can sell as much as they want at the market price. Well, if the market price is $200, they can sell as much as they want at $200. So that means no matter what quantity they sell, the price, which is, think about price whenever you buy something. It's how much you pay for a gallon of gas or a quart of milk or whatever it is you're buying. Total revenue, as always, is simply price times quantity. Right? So if you don't sell anything, it doesn't really matter. Right? Nothing times, or even if it was 200 there, right? Nothing times 200. Actually, let's put 200 there. Right? So, yeah. So price is $200, whether they sell anything or not. But since they're selling nothing, there is no revenue. So price times quantity, copy that formula down. And we have basically revenue going up by $200 every time they sell one more. Because every time they sell one more, they're selling it for the same $200 price. Marginal revenue. Okay, let's put the whole formula there. The change equals the change in total revenue. Right, so revenue goes up from 0 to 200 when I sell 1 ton, go from selling 0 to 1 ton of wheat, divided by the change in quantity, which is just 1 in this table. So this denominator I'm putting in here, dividing by 1 minus 0 isn't even needed right? It's only relevant if our table showed numbers going up by more than one, which is what it did in prior chapters, right? When we added workers, for example, to produce more books, because each time we added a worker, it didn't help us produce one extra book, it helped us produce multiple extra books. So our change in quantity was different than one, which is why we need, in some cases, need that, right? But even if I had left that bottom calculation off, it gives me the same number. Right? So I copy that formula down and notice, what do we get? Well, we get a pretty darn boring table, right? Price is always 200. Revenue always goes up, right, by $200 every time we sell one more, which literally exactly means that marginal revenue is in fact always 200. Right? So pretty boring, right? But important to understand why that's what it looks like and how it works. Okay, so let's move on, right? So remembering from part one, if this is our market demand for wheat, right, with the P star, the equilibrium price being $200, well, the individual farmer can sell as much as they want at that equilibrium market price. So the market price is the demand curve. And because of the math, right, that we just went over, because they don't have to lower the price, which is again demonstrated in this graph by the horizontal line at 200, horizontal demand curve, marginal revenue is the price. And in this case, we're assuming that that is $200. Okay. And again, highlighting that it's because they don't have to lower the price to sell a higher quantity, which is not an assumption most companies in most types of industries can make. But in perfect competition, it is assumed that simple. So here is the table that results, right, that we just calculated a minute ago in Excel. And here's what that table effectively, the first and last columns of that table looks like on the graph, right, which we just had on the previous slide, where, I should add the quantity there, where the horizontal axis, and the quantity, make sure everyone's clear, right, it's the supply and demand, so the horizontal axis is the quantity of wheat we're producing. I don't really want to edit the recording here, but just to be clear. So price, equilibrium price in the market, $200, that is our marginal revenue. So the first column is effectively, you can put the numbers here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tons. And marginal revenue is literally the last one, i.e. a dot at each ton, at each of those 10 tons at a price of 200. Right? Okay, so that's the revenue side of this. Right? However, to maximize profit, anytime you want trying to answer a profit question, revenue information is not enough. You need the cost side, right? Because total revenue minus total cost is profit. So, what is again, reminding the question we're answering, how should the firm, and again, highlighting, this is true for perfect competition, although the generalized conclusion, right, that is true for any type of competition, but it's this, it's a little bit simpler of a calculation or analysis in perfect competition because again the marginal revenue stays constant. Let's go do the calculation and come up to the rules. I'm going to jump to here. So let's do a little practice or on cost information, right? So as we did in chapter 11, right? So I gave this is information. Based on what's in this table so far, I can fill in everything else in this table. A little note: there's going to be, when we start taking the averages, right? There's going to be a little bit of rounding happening, right? But don't worry too much about that. So first thing makes sense to say, well, if it's $329 of fixed costs when we produce no wheat, well then it's $329 of fixed cost no matter how much wheat we produce, because that's what it means to be a fixed cost. Total cost, well, everything is either fixed or variable. Right? So when we take the fixed total cost equals fixed cost plus variable cost. So notice that a quantity of 0, or total cost, is our fixed cost because we don't need any seeds, right, or fertilizer if we don't produce any wheat. But then as we produce more, we need more raw material inputs. So all the variable things, including labor. So total cost, fixed cost plus variable. Marginal cost. Two ways I could get this number. I could either use the change in variable or the change in total, right? Because since fixed doesn't change, and because everything is either variable or fixed, all of the change, which is what marginal cost represents, how much total cost goes up when I make one more, could be calculated by either column. So before I fill this in, so think about this for yourself. So what is the marginal cost, for example, of the second ton of wheat? Well, it's either the variable or the total, right? But we'll use variable cost, all the variable costs of making 2 tons of wheat, so all the labor, all the materials, etc., minus how much variable cost we had to spend to make 1 ton of wheat, which is how much more variable costs we have when we make 2 tons of wheat than we did when we make 1, which is what marginal cost means. And this is implicitly being divided by the change in quantity going from 2 to 1, but since that's just 1, right, I don't have to put that in the formula. Okay, so marginal cost could have also been calculated in how it's normally described as the change in total cost when I make one more, but notice it will still be the 70 because of the reason I just talked about a second ago. Fixed costs don't change. Okay, so there's a marginal cost in this example. And then the averages, right? Average is always another per unit cost, just like marginal cost is, but meaning different things. So average total cost is all of my costs divided by the quantity I produce. Average of the variable cost is all of the variable costs divided by the quantity I produce. Average fixed cost is all of the fixed costs divided by the quantity I produce. Again, there's going to be a little rounding in some of these, so don't worry about the exact rounding numbers. So it might be off by a penny or two if you actually try to calculate this like off on the sides, or $1 or $2, I should say. But there's my table of information. So there's my cost stuff. Okay, go back. Okay, so now we have our costs. Now we have our revenues. So now we need to combine them, right? Because total revenue minus total cost is profit. So we need to utilize that to figure out with the appropriate piece of information what quantity this farmer should produce to maximize profit. Okay. So I've included in this table listed here some of the key revenue information needed to answer both this question and to be able to calculate how much profit they're making. Right. So there's the revenue stuff, and then also be able to include the relevant cost information to determine the quantity they should produce to maximize profit, and then to calculate at that quantity how much profit they're actually making. Right? So look at the two possible cost informations, one each for each answer. Okay. So at what quantity is, for each question, sorry, at what quantity is profit maximized when the price that they can sell their wheat at is $200? Well, you can't really go wrong as far as which. So the first thing you need to be able to recognize is what's the rule, and then so which column for both the revenues and costs do we use to get that rule. You can't really get it wrong in perfect competition on the revenue side, right? Because the numbers are the same, but you can get it wrong on the cost side. But the rule, just like it was when we introduced it in the last chapter, is we want to produce as long as the marginal revenue, right, of the next ton that we produce and sell is at least as big as the marginal cost. Okay, sorry, it was a little blip there, interruption. So say what I just said again. So you only want to produce as long as the marginal revenue of the next ton is at least as big as, i.e. greater than or equal to, marginal cost. Remembering we're talking about economic profit. So even if they're equal, zero's enough. you'll often actually see this formula as marginal revenue equals marginal cost. Because as we will see later, when we put this stuff on a graph, at some point the lines cross, so there's conceptually always a point where they're equal, although in a table of numbers like this one, they may never be equal, as they aren't in this case. But anyway, if this doesn't make intuitive sense to you yet, please study this in these terms and what they mean further, right? But if I say this instead without the terminology, and I just say, hey, I only want to produce more if my revenue goes up when I produce and sell 1 more ton of wheat by at least as much or more than my costs go up. I doubt that I assume that makes a sense to everyone. Well, that's exactly what this statement says. And if you can't equate those yet in your mind, I suggest you really think more and study more about what these terms represent, because that's all they represent. Okay, so at what point is this true? Well, again, it doesn't matter whether I look at the price column or marginal revenue for perfect competition, because they're the same, right? Because for all the reasons we've already just talked about, price and marginal revenue are always constant. They stay the same no matter how many tons of wheat we sell, and they're the same as each other as well. Okay, so when's the last time when marginal revenue, the amount of money coming in when I sell 1 more, is at least as much or more than the amount that the costs go up, the marginal cost, when I produce 1 more? Well, in this example, look down, look where, well, at 6 tons, marginal cost is 50, marginal revenue is 200. So marginal revenue is greater than marginal cost, in fact, by 50. So our economic profit goes up by 50 if we make and sell the 6th ton. Our economic profit goes up by $10 if we produce and sell the 7th ton, because our revenue goes up by 200. Our costs go up by 190, so $10 different. But if we produce and sell the 8th ton, our revenue only goes up by 200. Our costs go up by more than that. So if we made and produced the 8th ton, our profits actually go down by 40. So the last time when the price and the margin equaling the marginal revenue is greater than or equal to marginal cost is at the 7th ton. So at a price of $200, we produce 7 tons to maximize profit. Make sure that that is intuitively clear. Now, if the price is different than that, because sometimes prices fluctuate, so if the price and marginal revenue, if instead of all these numbers in these 2 columns on this table, instead of them being 200, they're 280, how many tons would we want to produce in that case to maximize profit? Look at the table, compare marginal revenue, marginal cost, and we want to produce 9 tons. Because if this was 280, and this is 280, even though our economic profit doesn't go up, right, when we produce the 9th ton, remember the mantra, 0 economic profit is enough. That means our accounting profit went up by enough to justify doing this, to justify making and selling that 9th ton. So that's where we maximize profit. Marginal revenue equals marginal cost, 9 tons. So to do one more example, if these 200s were instead $80 each, where price and marginal revenue is 80, well, then profit is maximized at 3 tons, because that's the last time, if these were all 80, where 80 is greater than or equal to 80, right? If you made the 4th ton, if this was 80, the marginal revenue is 80, your costs go up by 100, your profit would go down by, economic profit would go down by 20. Okay. So now, basically we've done the first of the 2 steps in the profit maximization calculations, right? We've determined the quantity that maximizes profit, right? It's going to depend on marginal revenue, produce the last, in this case, ton of wheat, or whatever we're producing, the last unit of production where the marginal revenue, which is the same as the price in perfect competition, marginal revenue greater than or equal to marginal cost. Once that's no longer true, you want to stop producing, right? And again, just mentioned for perfect competition, those 2 things are the same. When we get to the monopoly chapter, and for the other types of competition, incidentally, price and marginal revenue will not be the same, but here they are. Okay. Now, so far we have not done enough to calculate how much profit we're making when we're doing the best we can. Be clear on that, right? When we're looking at the marginal information, that's really important to tell us what to do, but it doesn't tell us yet how well we're doing in total, because the marginal information, especially doesn't tell us how much in total, right, we have revenues and costs, especially in costs, because the marginal cost doesn't tell us anything about our fixed costs. All we've determined is what quantity we should produce to do the best we can to maximize profit. Now we have to determine, right? Now we have to determine how much profit that is. And as just mentioned, that does not depend upon how much our costs and revenues go up on the last ton. It depends on all of our costs and all of our revenues. So we don't need the marginal information. We need the averages and the total information, right? Because profit is actually calculated as total revenue minus total cost. So let's do the second step using the same information. And again, I've pulled out that key information from the spreadsheets that we went over before. And this basically has that information calculated. And simply what we would need to look at is to purely do what's on this last slide, right? Total revenue minus total cost. Well, I've included that here, right? Total revenue minus total cost is profit. And I'm reminding us, although it's not usually put in these tables, right, on the book or in homework problems, that we're talking about economic profit, and which makes zero good enough. We're not counting profit. That wouldn't be true, right? Usually it just says profit. Okay, so profit, total revenue minus total cost at a quantity of 7. Total revenue $1,400 minus total cost $1,089. Now, please note there's a little bit of rounding in some of these numbers, so it's going to be off by a little, like a buck or two if you actually do it offline or in Excel, if you don't round. But $311, right? Total revenue minus total cost, economic profit, $311. Now, we're going to spend a lot of time, right, soon in the last parts of this discussion, not looking at tables of numbers like this, where you actually see the numbers, but as we often have with supply and demand and other things, on graphs, and as we did in Chapter 11, where we graph the unit cost information, right? We graph the average total cost, average variable cost, average fixed cost, marginal cost. We're going to graph the marginal revenue and the price, right? So we need to not just be able to see this as total revenue minus total cost, but we need to be able to calculate this as what is the profit per unit times how many units you sell, right? Because that, trust me, that will be, if you can see it that way in the calculations, it'll be easier to see it on the graph. Okay. Well, the revenue per unit is always price. That's literally what price is. If you sell, price times quantity, that's my revenue. So revenue per unit is the price. What's my total cost per unit? Well, the average of all of my costs. Average is always per unit, so the average total cost is your cost per unit. So your profit per unit, just like your total revenue minus your total cost is your total profit. Your profit per unit, price, minus your cost per unit, average total cost, is your profit per unit. So if you take that profit per unit, multiply it by the number of units, right, the quantity that you're producing, you get the total profit. Profit per unit, price minus average total cost, times the quantity gives the total profit. Let me move this down, right? So if we put those numbers in at a quantity of 7, where the price is 200, the average total cost, right, like between 155, 156, multiply that times a quantity of 7, we get the same profit of 311 as we got before. So for all kinds of reasons, and not just the graphing ability to see it, but it's important to be able to recognize, well, what's my profit per unit at the level of production I'm producing, times the quantity gives me my total profit. Now, again, this is the easier version to see on the graph. So here's a graph that's not literally these numbers, but it's close enough, right, to have this graph represent it, right? Well, this horizontal red line is my price equals marginal revenue, as we've talked about. They're the same. Imperfect competition stays constant. So there's my revenue info. If my quantity I'm producing is 7, well, then everything I care about is where are each of these lines intersecting that quantity, right? So I'm basically looking up from there to say, okay, well, I know my price is 200, no matter what the quantity was. But I'm looking at where that kind of imaginary vertical line from a quantity 7 hits my average total cost, because that is, right, quantity of 7, average total cost $155.55. Well, that's where that is, right? So there's that 155.57. And if I do that calculation, the price of 200 minus the 155.57 times the quantity of 7 tons, I get a profit per unit of the difference, right? 44.57 times quantity of 7. And that's that box, right? It's important to recognize, to be able to see that that box represents the profit. Profit per ton is the difference in the height, right, of the price minus the average total cost, times the number of tons. So that area of that rectangle is 7 quantity, times the difference between price minus average total cost. So that size of that rectangle is $311. Now, what if, so make sure that's clear. What if instead of average total cost being here, average total cost was up here? Where would we maximize profit? Well, we would still, quote unquote, if we're going to keep producing, we would still maximize profit, right, at the price, at the quantity, at the quantity at which, I'm going to get rid of this, get rid of that for a second, get rid of that, right? These numbers would no longer be true on the cost side. So we would still maximize profit, right, if we're going to keep producing at a quantity 7, where marginal revenue equals marginal cost. But what would be true of that amount of profit? This calculation is no longer accurate, right? These things, because the cost is higher now. Well, it would mean that we would go up to here, right, to get the amount of the average total cost. And it turns out the average total cost is greater than the price. Well, whenever the average total cost is greater than the price, we have a loss. So under this cost structure, if the average total cost was way up here as opposed to where it was initially, we would be losing money even at the best we could do. Right? So as we will see here shortly, that might mean we go out of business in the long run. It might mean even in the short run we shut down. We'll talk about that, those kind of decisions later. But the decision of how much to produce, if we're going to keep producing while we're losing money, well, we're still going to want to produce at the quantity where marginal revenue equals marginal cost, because that's still going to be the best we can do, even if the best we can do kind of stinks, or even if it's a loss. So let's move on. Actually, let's move on to part 3. So that's the end of part 2, and we will, in part 3, kind of explore, so what do we do in situations like that when the best we can do is losing money.